Alright, so in this video we're going to be talking about another type of transformation called a reflection over the x-axis. So there is a reflection over the y-axis, but we are not going to be going over that this year. So we're going to focus on just the x-axis reflection. So again, the stuff I've circled in red is like your generic formal version of what this reflection looks like. And basically it just means there's a negative in front of your y, since f of x is y. So we're basically taking y value in our function and we are making it negative. We're switching the signs basically. So if a negative is on your leading coefficient, you have reflected across your x-axis. So here's what that looks like just in brief. If I have y equals 2x plus, let's say, 4, my leading coefficient is 2. It's the first coefficient I have. It's the only one I have here. And it has no negative, so we have not reflected. However, if I say negative 2x plus 4, now this leading coefficient has a negative in front of it, which means we're now making all those y values going to be flipped. So we are going to be reflecting across the x-axis. So to give you an idea of what I mean by we're making all the y values the opposite, we're making them negative. On the left here you have your parent function for your linear graph again, y equals x, and on the right we have y equals negative x. So I just picked a few input values, negative 2, negative 1, 0, 1, and 2, and we plugged them in, and on the left, of course, they're going to be the same because it's y equals x. But on the right, if you plug in negative 2, we're now doing negative, negative 2, which is a positive 2. It switched the sign, so y changed signs. If you plug in negative 1, it's a negative, negative 1, which is a positive 1. And then when you do your positives now, they're going to turn negatives. So we're switching signs basically when we're making this leading coefficient negative, which means we're reflecting across this x-axis right here. So notice like the point 2, 2 has now come down to 2, negative 2. It's reflected across the axis. And points down here like negative 4 have come up to negative 4, positive 4. So we are just reflecting across this horizontal axis. And it's kind of easier to see with functions like these that have curves in them on both sides, because the lines, it's kind of hard to notice what is moving and when it's moving. So this is called a quadratic. You're not responsible for it this year, but it's y equals x squared as the parent, the one up here. And again, all I did was add a negative in front to denote we're going to be reflecting, and here's what it looks like if you were to go make table values for this and plug it in. You'd just be flipping across, or down if you will, the x-axis. So, real quick, which ones of these are reflected across the x? All you're hopefully looking for at this point is saying, oh, I just need to find the ones that have a negative out front, which is what you need. So on number 1, there is no negative on your leading coefficient, so that does not reflect. Number 2, however, has a negative out front, so that one does reflect across the x-axis. Number 3 doesn't have one, so it's not reflecting. Number 4 has a negative out front, so this exponential is reflecting across the x-axis. Remember, you can do it to any function. Number 5 doesn't have a negative, so we're not reflecting, but number 6 does, so this exponential is reflecting as well. So here's your practice questions, and again, this is pretty quick and easy, as long as you can identify negatives. So real quick, just write the number down. You don't have to write the equations unless you want to, but go and determine which ones of these are reflecting across the x-axis, and pause the video and come back in a minute and check. Alright, here you go. So number 1 has a negative out front, so we are reflecting. Number 3 has a negative out front, so we're reflecting. And number 6 has a negative out front, so we're reflecting. All the other ones have just stayed in the position they were originally intended to be in. Alright, so until next time, keep practicing.